When we are integrating something in the form, so some bracket to a power times by that bracket differentiated, we can reverse the chain rule. So here we can see we've got a bracket which is around our sine x. So we've got sine x squared, and that is multiplied by the bracket differentiated, which is cos x, and it can be any multiple. We can have any constant there as well. It's reversing the chain rule. So this answer could come from the chain rule, so we can reverse it. So what did we have to start with that we differentiated to get this? It's going to have to be a sine x cubed, because when we differentiate, we take one off the power. So it's going to have to be something like sine x cubed, sine cubed x. And what we can do is we can just start with this, differentiate it, and see what happens. So we get dy dx. So when we differentiate, we times by the power, take one off the power, and then times by the bracket differentiated. That is the chain rule. So we're going to get 3 sine squared x times the bracket differentiated, which is cos x. Is that what we wanted? Is that the same as our answer? Well, we wanted a 2 sine squared x cos x, not 3. So we can fix that by multiplying it by 2/3. If we multiply our answer by 2/3, that means we multiply our original function by 2/3, because when we're differentiating and integrating, any constant just stays there. It's not affected by the differentiation or integration. So we have our answer. This must be our answer. So the integral of 2 cos x sine squared x with respect to x is 2/3 of sine cubed x plus a c. If you are able to do this one, pause the video and give it a go. Otherwise, keep watching and we'll have it as another example. So again, we have a bracket. This time it's x squared plus 3. And we can see it's multiplied by the bracket differentiated. Again, we're ignoring the constants, so it can be any multiple of it. So the bracket differentiated is 2x. So x is a multiple of that. So it comes from reversing the chain rule. So what would it have looked like? So let's say the original, we just add 1 to the power, is some multiple of x squared plus 3 to the power of 4. So we're just adding 1 to the power, then we're going to differentiate and see what we get. So dy dx would be times by the power, take 1 off the power, times the bracket differentiated, which is 2x. So that will give us 8x times x squared plus 3 cubed. Is that what we wanted? Well, no, we didn't want that 8. So how can we get rid of it? We times by 1/8. And if we times our answer by 1/8, that means we times what we started with by 1/8, which makes this our answer. So the integral is 1/8 of x squared plus 3 to the power of 4 plus a constant. So if we differentiate this, we get back to our question. It's reversing the chain rule. Here's another one. Again, a bracket. If we differentiate the bracket, we'll get 2x plus 1. So it's multiplied by the bracket differentiated. So we can reverse the chain rule. So let's say that we start with x squared plus x plus 5, and we're going to add 1 to the power, so it would be the power of 5. What happens when we differentiate this? So we times by the power, take 1 off the power, and times by the bracket differentiated, which is 2x plus 1. Is that what we wanted? No, we've got 5 that we don't want. So we're going to times it by a fifth. And if we times our answer by a fifth, that means we times what we started with by a fifth. And that makes this our answer. So it is 1/5 of x squared plus x plus 5 to the power of 5 plus a constant. One for you to try. See if you can give this a go. So when we differentiate cot, we get negative cosec squared. So we're going to say that this is our bracket, and this is our bracket differentiated. So what are we going to do? We're going to start with adding 1 to the power, which would be cot squared x, and then differentiate and see what we get. So dy dx times by the power, take 1 off the power, and times by the bracket differentiated. So that would be negative 2 cot x cosec squared x. That's similar to what we wanted, but we wanted 3 times, not negative 2 times. So we're going to times by negative 3/2. And we times what we started with by negative 3/2, which means our answer is negative 3/2 cot squared x plus a constant. So if we differentiate negative 3/2 cot squared x, we get back to 3 cot x cosec squared x. We've reversed the chain rule. Here we have a bracket, which is now the power of the bracket is a negative 1, and it's times by some multiple of the bracket differentiated, which would be 2x differentiated. And because it's power of negative 1, this one is going to be a log. So it's going to be something like log x squared plus 2. Then we're going to differentiate it, see what we get, and then adjust for any constant. So dy dx. So when we differentiate a log, it goes to 1 over x squared plus 2 times the bracket differentiated, which is 2x. So it's going to be 2x over x squared plus 2. Is that what we wanted? No, we want to half that. We don't want the 2. So times by a half. So that's times what we started with by a half. And that will give us our answer. So it's half of log x squared plus 2 plus a constant. And another one for you to try. So we've got our bracket and our bracket differentiated. So we're going to be logging. It's going to be a log because it's on the denominator. So 1 over x integrates to give log x. Log x differentiates to give 1 over x. So y is something like log 2 tan x. If we differentiate that, dy dx is 1 over 2 tan x times the bracket differentiated, which is 2 sec squared x. So that will be sec squared x over tan x. Is that what we wanted? No, we want a 2 on the denominator. So we're going to times it by a half, which means we times what we started with by a half, which gives us our answer of log 2 tan x, half of log 2 tan x, plus a constant. another one. So again, it's going to be a log one. We've got our denominator, and then which is our bracket, and it's times by that bracket differentiated. So it's going to be something like log e2x plus 2. So differentiate, which goes to 1 over e2x plus 2, times the bracket differentiated, which is 2e2x. 2e2x. So we've got 2e2x over e2x plus 2. Is that what we wanted? No, we want to get rid of this 2. So times it by a half. So times what we started with by a half. So our answer is half of log e2x plus 2 plus a constant. One for you to try. See if you can give it a go. So again, we've got a bracket, which is here, and a bracket differentiated. It's multiplied by a bracket differentiated. The bracket, our original one, is on the denominator, but it's not a log this time because it's a power of 2. So it's the same as cos x times 2 plus sin x to the power of negative 2. So it's just a bracket, and multiplied by its bracket differentiated. So we're going to add 1 to the power, and that'll be what we start with, which will be 2 plus sin x to the power of negative 1. And then let's differentiate that and see what we get. So dy dx is minus 2 plus sin x to the power of negative 2 times the bracket differentiated, which is cos x. So we have negative cos x over 2 plus sin x squared. Is that what we wanted? We want to get rid of the negative, so times it by negative 1. So we get our answer. So we get negative 2 plus sin x to the power of negative 1 plus a constant. And one more question. So we have our bracket, and it's times by a multiple of the bracket differentiated. The power of the bracket at the moment is a negative 1. It's 1 over. It's going to go to a log. So we are going to have something like log x squared plus 5. If we started with that, what would we get? We would get dy dx as 1 over x squared plus 5 times the bracket differentiated, which is 2x. That's not what we want. We don't want 2x over x squared plus 5. We want to half it. So times it by a half. So we have half of log x squared plus 5. And we've got two limits, which are 5 and 2. So we're going to substitute in 5, substitute in 2, and take them away. So we've got half of log, so 5 squared plus 5 is 30, minus half of log 2 squared plus 5, which is 9. And I'll just leave it. I'll just leave it in exact form. I'll leave it like that. One for you to try. See if you can give it a go. So we have a bracket differentiated is 3x squared plus 2. So it's times by the bracket differentiated. So we can integrate by reversing the chain rule. And let's say that we start with x cubed plus 2x minus 1 and add 1 to the power. So if that was what we started with, dy dx would be 4 times x cubed plus 2x minus 1 to the power of 3 times 3x squared plus 2. So we've got a 4 that we want to get rid of. So let's times it by a quarter. So we get a quarter of x cubed plus 2x minus 1 to the power of 4. Then we're going to substitute in 2, substitute in 1, and take them away. So we have a quarter of 2 cubed, so 8 plus 2 2's, 12 minus 1, 11 to the power of 4, minus a quarter of 1 plus 2 minus 1, so 2 to the power of 4. And let's just type that into the calculator. And we get an answer out of 14,625 over 4.